Hey guys, let's take a look at this question where we are using inequalities. This is a system of inequalities. So let's see if we can make sense of it. And we're going to use Desmos as part of the process. It says that Maya has two jobs. She wants to work no more than 14 hours a week, and she needs to make at least $150 each week. So the bakery pays $10 an hour. The florist pays $11.50 an hour. What's a reasonable number of hours she can work at each place and meet her goals? And so we're going to come up with the number of hours at the bakery, the number of hours at the florist, and so on. Okay. Lots of things to think about. I was reading through it quickly. So if you want to pause and kind of look at that, you can for sure. That would be a good idea. All right. So we're talking about number of hours she can work, and how much money she's going to make and that sort of thing. So let's assign some variables. Let's call the first one X and the second one Y, right? And these are the number of hours for both of them. Okay. Number of hours she works at the bakery. Y is the number of hours she works at the florist, just to keep it simple. So let's say she wants to work no more than 14 hours a week. So when we add up the hours that she works, it needs to be no more than. So sometimes that's hard to think through. Not more than, meaning less than that would be okay. She'd be fine if she could make that much money in 10 hours a week or 8 hours a week, right? But she doesn't want to work 15, 20, 25 hours. She's got school, she's got volunteering and other things like that. So she's busy. So no more than means less than or equal to 14. And then she wants to make at least $150 an hour. So is she okay with $100? I mean, a week, not an hour. No, not $100. She would not be okay with that. She's needing 150 or more, right? 150 is the minimum. So $10 at the bakery plus $11.50 at the florist needs to be greater than or equal to 150. It could be equal to 150, but more than that would be just fabulous, right? That'd be great. Okay, so here are our two inequalities, not equations, but inequalities. Now, I will say that I see that a lot of you are having to solve these for y and give an answer in terms of y. So let me, let's see, that was less than or equal to 14. Okay, so let's solve this for y. So we're going to subtract x from both sides. Bring down the y and the less than or equal to, and then 14 minus x. Now, if you're having to graph this yourself, you're probably going to have put negative x plus 14. So you've got it in slope intercept form. But we can leave it just like 14 minus x for this process. I'll show you on Desmos in just a moment. That's just if you need to solve. I wanted you to have a chance to see that. And then here we can see if we want to solve for y, we're going to subtract 10x from both sides. I don't want to write 10x under 150 because I don't want to be tempted to subtract those numbers when they're not like terms, right? So that leaves me 11.50y is greater than or equal to 150 minus 10x. Let's divide by 1150. Okay. So calculator. Let me drag that over here. And let's see, 150. Let me turn off my pen. 150 divided by 1150. 13.04 or 300 over 23. All right, well, we're going to approximate. Y is greater than or equal to 13.0435. I'm going to not round that very much if I can help it. Okay. And then 10 over 1150, 10 divided by 11.5 or 11.50. All right. Minus 0.8696. Okay. Let's see if that'll reduce. It does reduce a little bit better, but I think I'll I'll leave it this way for now, and that has X on it. So if you put 20 over 23X, that would be a more precise, more exact answer. Just know that. And I like that this doesn't come out pretty, it doesn't come out as clean as we might like it, because that is real life. Okay. So I'm going to go to Desmos and type in y is less than or equal to 14 minus x. Look at there. Isn't that interesting? So let's slide that over some. And I'm going to do another one and do this other one down here. Y is greater than or equal to 13.0435 minus 0.8696x. Okay. All right. So let's take a look. Oh, this is fascinating. Okay. So we have it graphed nicely. So I'm not focusing so much on the graph here, on the graphing part. I have other videos where I focus more on how to graph these. We're going to focus on finding our solutions. We have a very narrow window. Maya does not have tons of options, right? If she wants to keep her work hours low, but make a certain amount of money, it's pretty tight right here. So let's zoom into that and see. Remember that X was the bakery hours. So let me write that down. X is the bakery. And remember, this is our x-axis over here. And our y-axis up here is the florist. Okay. So Maya can work any of these places where it's this, inside of this section right here. Those are the hours that work for her. So let's see. That number looks like it would go there, but it doesn't really. Could she work exactly 2 and 12? That would work. She could work 2 hours. That's on the x-axis, 2 hours at the bakery and 12 hours at the florist. Right? She could work 4 hours at the bakery and 10 hours at the florist. Let's see, 3. If she was at 3 hours, she would need to be about 11 hours at the florist. So right in there, very short range, right? She wouldn't make enough money if she only worked at the bakery, because there's nothing on the x-axis that is in the blue section for the florist. There's no overlap there. She's going to have to work at most 7 1/3 hours at the bakery. Think about why she would want to work more hours at the florist. Think back to what she makes at each of those. She only makes $10 an hour at the bakery, but $11.50 at the florist. So it makes sense, right? If she worked 14 hours at the florist and did not work at the bakery at all, she would earn her money. So it looks like overall, in order to make that money, she's going to have to work 13 or 14 hours. She's really not going to be able to make the money if she works any less than her maximum amount. So, all right. So those kinds of answers, and several of those things, would be answers to that question. I hope that helps you to think through and reason through systems of inequalities. All right. I'll see you next time.